Hey, and welcome back to the channel. Everybody's been lately talking about the Steam machine, but with the price increases of DRAM and GPUs, it's questionable at what price it will sell for. They are estimating around 900 to 1100 euros, depending on the SSD size, and that's quite a bit, isn't it? So I decided to build my own SteamOS machine, probably faster, cheaper, and better. I hope so. Let's find out. Before we start with my build, let's take a look at the upcoming Steam machine and what we know so far. The system is reported to use a semi-custom AMD Zen 4 CPU with 6 cores and 12 threads, boosting up to 4.8 GHz and running at roughly 30 watts TDP. That is a modern architecture, but clearly designed for efficiency and a compact cooling solution, very similar to a console-style platform. On the graphics side, the Steam machine is expected to use RDNA 3 graphics with 28 compute units. But what's really important here is the power envelope. The GPU is reported to run at around 110 watts, with the entire system powered by roughly a 200 watt power supply. That's great for efficiency, thermals and noise levels, but it also means the GPU performance is naturally limited compared to a full desktop graphics card. Another key detail is the 8 GB of VRAM. 8 GB can still be fine for many games, especially at 1080p, but in newer AAA titles, particularly with higher textures or at 1440p, VRAM can become a real bottleneck. The system is also reported to ship with 16 GB of DDR5 memory and 512 GB or 2 TB of NVMe storage, depending on the model. And finally, there's the price. Early retailer leaks suggest around 900 to 1000 euros for the 512 GB model and roughly 1100 to 1200 euros for the 2 TB version. And at that point, we are not really competing with consoles anymore, or at least entry-level consoles. We are competing with full gaming PCs. So that's the baseline, a compact, efficient SteamOS machine, but with an 8 GB GPU, a tight power budget, and a price approaching a full desktop build. So let's see what we can build ourselves for significantly less. Here's the system I put together instead, focusing on more graphics power, more VRAM, and significantly lower cost. For the GPU, I'm using an AMD RX 6750 XT Pulse, which comes with 12 GB of VRAM. Compared to the Steam machine's reported RDNA 3 GPU with 8 GB of VRAM and around a 110 watt power limit, this gives us significantly more graphics headroom, especially at higher settings or 1440p gaming. For the CPU, I went with the Ryzen 5500, a 6-core 12-thread processor. On paper, the Steam machine's Zen 4 CPU is newer and more efficient, but for gaming workloads, both CPUs sit in a similar class, and in this build, the GPU is the main performance driver anyway. The motherboard is an ASRock B550M ITX, keeping the build compact while still offering full desktop upgradability, something a console-style system typically doesn't provide. For memory, I'm using 16 GB of DDR4 at 3200 megatransfers per second. The Steam machine uses DDR5, which is technically faster, but DDR4 is still perfectly capable for gaming, and significantly cheaper, especially right now. Storage is handled by a 1 TB SSD, which sits nicely between the Steam machine's 512 GB and 2 TB options. The case is the Deepcool CH160, keeping the system compact and suitable for living room gaming, similar in spirit to the Steam machine concept. Cooling is provided by the Thermal Ride Assassin King 120 SE, which even came with thermal paste included. Awesome. And for power, I'm using a Corsair SF600 Platinum, which gives the system plenty of headroom compared to the Steam machine's much tighter power budget. Most of these components were bought used or open box, often with some form of warranty, which is a great way to stretch the budget without sacrificing performance. And the total cost for this entire system comes out to around €650. Of course, your mileage may vary and the prices fluctuate, so patience is key when looking for used components. Under €700 in total, this is significantly cheaper than the expected €900 to €1,100 range for the Steam machine, while offering more graphics power, more VRAM, and full PC upgradability. And now it's time to put it all together, download and install SteamOS, and then run some benchmarks. Let's go! Here we go. After a short moment of memory training, we are greeted by the BIOS screen telling us the CPU changed. So let's hit Y and get into the BIOS to tweak some settings. First of all, on a new build I always do a quick BIOS update to the latest version. This takes a moment, so please don't power off the system while the BIOS is updating. I sped up the video dramatically, cause we don't want to wait here too long, right? But be patient. Do the reboot and re-enter the BIOS, cause we still need to tweak some settings, right? As you can see, we are running at 2666 megatransfers per second, so we need to activate the XMP profile of the RAM to get to the 3200 megatransfers per second these modules are capable of. The second setting we want to change is the secure boot. Although we can get SteamOS to work with it, for the fresh installation and normal usage, it is easiest to just turn it off and leave it alone. The last setting we want to enable is above 4G decoding. This is a mandatory requirement for enabling resizable bar or rebar, a feature that allows the CPU to access the entire GPU VRAM at once for improved gaming performance. And that is what we want. For better out-of-the-box hardware support, for example newer GPUs like RDNA 4, I used the SteamOS 3.8 main recovery image from Valve's official servers. The direct download link is in the video description below. I then flashed the image to a 16GB USB stick using Berliner Etcher on a second PC, and with that we are ready to install SteamOS on our self-built Steam machine. Next, plug the USB stick into your system, power it on, and boot from the USB device. Depending on your system, you may need to open the boot menu or adjust the boot order in the BIOS. The first boot from the USB stick can take quite a while, so don't worry if nothing seems to happen immediately, just give it a moment. After a short wait, you should be greeted by the SteamOS recovery environment, which in this case loads into a KDE Plasma desktop with several installation and repair options. Once the desktop loads, you'll see several options available, including repair tools, reinstall options, and others. For a clean installation, we want to select Wipe Device and install SteamOS. After clicking it, a confirmation window appears warning that the device will be wiped and that the process cannot be undone. Since we're doing a fresh install, we can safely click Proceed. The installation then starts automatically. SteamOS will download the required components and begin installing them onto the system. This process can take a few minutes depending on your hardware and internet connection, so just let it run. Once everything is finished, you'll see a re-imaging complete message. From here, simply click Proceed to reboot into your freshly installed SteamOS system. After the reboot, we'll be greeted with the SteamOS first-time setup. First, select your language, then your time zone, and finally connect to your Wi-Fi network. These steps are pretty straightforward, so I'll speed up this part. Once that's done, SteamOS will automatically check for updates and begin installing them. The system will then restart once more to complete the setup. After the final reboot, you are ready to sign in into your Steam account, and with that, your self-built Steam machine is almost ready to go. You might notice something a bit odd here. The colors look washed out and faded. This is a known issue when running SteamOS on standard PC hardware. In some cases, SteamOS incorrectly enables HDR output, even when the display doesn't fully support it. When that happens, the colors appear dull and low contrast. Thankfully, the fix is very simple. We just need to open the display settings and switch from HDR to SDR mode. And there we go. That already looks much better. While browsing the Steam library, I noticed something odd. My physical keyboard was using the US layout instead of German. So I headed into the SteamOS settings in gaming mode and added the German keyboard layout, then set it as default. But here's the catch. This setting only affects the on-screen keyboard. The physical keyboard layout doesn't actually change in gaming mode, which is a bit unfortunate. At the moment, there doesn't seem to be a direct way to change the hardware keyboard layout from gaming mode itself. It's a small issue, but something to keep in mind if you're using a non-US keyboard layout. Maybe we can fix this in desktop mode? We'll check that later. With SteamOS up and running, it was finally time to launch the first game and run a benchmark, in this case Shadow of the Tomb Raider. But almost immediately something felt off. Even with VSync turned off, the benchmark stayed locked at a perfectly steady 60 frames per second. I checked the in-game settings, I checked SteamOS gaming mode, and I double-checked refresh rate and sync options, but nothing I changed made any difference. And this actually seems to be a known quirk of SteamOS gaming mode. On some systems, especially with external displays or non-Steam Deck hardware, the GameScope session can end up outputting at 60 Hz, even when the display itself supports more. So in this case, the 60 FPS cap didn't appear to come from the game itself, but from the way SteamOS gaming mode was handling display output. So the benchmark was working, but gaming mode was clearly getting in the way. To investigate further, I switched over to desktop mode. One of the advantages of SteamOS is that it's actually a full-fledged Linux distribution based on Arch Linux, with a KDE Plasma desktop environment available alongside gaming mode. This means you get access to a familiar desktop where you can easily adjust system settings, like keyboard layout, audio devices, and display configuration, and more. So I quickly set the correct keyboard layout, then changed and double-checked the display settings. But the real question was, would this actually fix the 60 FPS limitation? So I launched Shadow of the Tomb Raider again and ran the benchmark one more time. And this time everything worked as expected. The benchmark was no longer capped at 60 FPS and the system was finally able to run at the full refresh rate. So it looks like the limitation was specific to gaming mode, while desktop mode allowed the system to perform as intended. While further testing, I also noticed another limitation in gaming mode. In gaming mode, it seemed like I couldn't switch the resolution to 1440p, with the system staying locked at 1080p. In desktop mode though, I had no issues switching the display resolution to 1440p. So not only was desktop mode able to run the benchmark uncapped, it also allowed the system to use the full display resolution. With everything working correctly, it was time for benchmarks. I tested several games at 1080p and 1440p while also monitoring temperatures and noise levels to see how this compact Steam machine alternative performs in real-world gaming. Alright, let's take a look at the benchmark results. All tests were run at 1080p and 1440p using mostly high to maximum settings and without upscaling unless noted. Starting with Doom: The Dark Ages, we are seeing around 90 FPS at 1080p and 71 FPS at 1440p using FSR quality. That's a demanding title, but still very playable at both resolutions. In Shadow of the Tomb Raider, performance really shines. 155 FPS at 1080p and 126 FPS at 1440p on the highest preset without upscaling. Red Dead Redemption 2 comes in at 93 FPS at 1080p and 77 FPS at 1440p using Vulkan with balanced settings. A solid result for such a heavy open world game. Horizon Zero Dawn Remastered performs well too, with 88 FPS at 1080p and 81 FPS at 1440p, showing minimal scaling loss between resolutions. And finally, Cyberpunk 2077, one of the most demanding titles here, delivers us 111 FPS at 1080p and 72 FPS at 1440p on high settings without upscaling. Overall, this build is clearly very strong for 1080p gaming, consistently pushing well above 60 FPS, and even at 1440p, most titles remain comfortably playable. For the most demanding games, enabling something like FSR quality can help maintain higher frame rates without sacrificing too much visual quality. And just one note, all results shown here are based on in-game benchmarks to ensure consistent and comparable results. Now let's take a look at power draw, noise levels and temperatures. At idle, the system pulls around 33 watts, and while navigating SteamOS, that increases slightly to about 55 watts, which is very reasonable. During normal gameplay in SteamOS gaming mode, power draw sits between 150 and 200 watts, which peaks around 250 watts during benchmark runs. Noise levels are very low here, measuring around 30 decibels at 20 centimeters, which was close to the minimum measurable level in my setup. Temperatures also stay well under control, with the GPU reaching about 65 degrees Celsius and the CPU around 60 degrees. Under a full stress test, combining a game loop with artificial CPU load, power draw increases to around 300 to 325 watts and noise rises slightly to about 35 decibels at 40 centimeters. Even then, temperatures remain very reasonable, with the GPU at 65 degrees and the CPU around 75 degrees Celsius. Overall, the system is not only powerful, but also surprisingly quiet and well behaved under load. Important context: gaming mode was measured with a 60 FPS cap, while the full stress test run in desktop mode without any FPS cap and with an additional artificial CPU load from GTK stress testing. So that results closer to a worst case scenario than normal gameplay. So, after spending some time with the system, there are definitely a lot of things to like here. From a hardware perspective, the value is honestly very impressive. For around €650, this build delivers excellent 1080p gaming performance, very capable 1440p results, 12GB of VRAM, and a fully upgradable AM4 platform. And despite the compact ITX form factor, the system also stays surprisingly quiet and cool under load. SteamOS itself is also genuinely enjoyable to use when everything works as intended. Gaming mode felt fast, clean, and very console-like, especially when paired with a controller from the couch. But there are definitely still some rough edges. In my testing, gaming mode had limitations with refresh rates, display resolution, and keyboard handling, while desktop mode fixed most of those issues immediately. So if you just want a simple console-style gaming experience, SteamOS works very well. But the moment you want deeper control or customization, you'll probably end up spending time in desktop mode. So, after building and testing the system, what's the final verdict? From a pure hardware perspective, this build is honestly very impressive for the money. I might sound like a broken record, but for around €650, it delivers strong 1080p performance, very capable 1440p gaming, 12GB of VRAM and full desktop upgradability, all while staying relatively quiet and compact. Compared to the expected pricing of the upcoming Steam machine, this DIY build likely offers more raw graphics performance and better value overall. SteamOS itself is also genuinely promising. Gaming mode creates a very clean and console-like experience, and during the time I recorded this video, Valve was actively pushing out updates that already fixed some of the issues I initially encountered, including the HDR problem and the display resolution behavior in gaming mode. So, credit where credit is due, Valve clearly seems to be working hard on improving SteamOS ahead of the Steam machine launch. The keyboard layout issue for non-US layouts still remained for me during testing, although this also appears to be addressed in an upcoming update and is already present in a beta release. Because of that, I added labels and notes throughout the video instead of re-recording entire sections, whenever something changed or got fixed during production. Right now, SteamOS already works very well if your goal is a simple couch gaming experience. But if you want deeper control over display settings, refresh rates, keyboard behavior, or advanced settings, you'll still occasionally end up in desktop mode. So overall, I'd say this. The support on the hardware side is already very good. SteamOS is getting better very quickly. And with a few more updates, this kind of setup could become a genuinely fantastic alternative to a traditional gaming console or even Valve's own Steam machine. And this definitely won't be the end of this project. Next, I want to test a CPU upgrade to unlock more of the potential of the GPU, try a different Linux distribution focused more on full desktop usage rather than the console experience, and eventually even build an all-Intel Linux gaming machine to compare against this AMD-based setup. And with that, that's it for today. If you enjoyed the video, feel free to leave a like and subscribe so you don't miss future videos on our little tech adventures. There's definitely a lot more coming, more Linux testing, hardware upgrades, benchmarks, weird experiments, and probably a few unexpected problems along the way. Thanks for watching, and I'll see you in the next one.